Lissajous clock. Having previously made a couple of clock projects with different themes, I wanted to retain differentiation on the next clock theme project. Therefore, there would be no new puzzles or mechanical indicators, and in the case, elected to use an LCD display. Yet another departure was with regard to the microcontroller, which previously had been a microbit, and this was to use a Raspberry Pi Pico. However, not wanting to go for a classic numeric display, the plan was to display the time using Lissajous figures in style for carriage clock using wood, acyclic and brass. The attached video showed 29 minutes compressed in 27 seconds. Supplies: Raspberry Pi Pico Lipo, Pico Display, Pico Omnibus, RGB encoder breakout, RV real time clock switch as PDT, brass sheet 0.5 mm, acrylic sheet black, acrylic sheet clear, vent dial, straight pin header, right angle header, straight PCB socket, lipo battery, strip board, jumper wires, handle, bow tie. Screws. Tools: step cone drill bit 4 to 12 mm, 2 mm drill bit, 5 mm drill bit, 7 mm drill bit, 9 mm counter sink bit, 8 mm counter sink bit, 10 mm counter sink bit, 12 mm 2 mm Allen key, 4 mm Allen key, saw, drill, oscillating meter, combination square, scribe marker, soldering iron, solder, clamp, sander. Step 1. Lissajous figures. Different patterns will be produced by the variation in frequency and phase between the two input stimuli. Lissajous figures are used in many areas: acoustic, electronics, and communication, to name a few areas. If we use Excel as our display for our command waveform, assume two sinusoidal waveforms of the same amplitude, phase, and frequency, one assigned to the x-axis and one on the y-axis, representing our two tuning forks, with one revolution equal to 2 pi radiation or 360 degrees, will range from -1 to +1. If the phase difference is 180 degrees, then the straight line displayed will be at 135 degrees. If we change the phase of one of the waveform by 90 degrees, x sin t plus 90 degrees, y sin theta cos theta, plotted on x and y chart, will be produce a circle. If we vary the frequency of one waveform with respect to a fixed reference frequency, the resulting Lissajous figures will display multiple curvatures, each curvature related to the ratio of varying frequency to the reference. Step 2. Lissajous numbers. Knowing that different Lissajous figures can be created by varying the input frequency with respect to a reference frequency, it's only a small step to realizing these figures in terms of numbers. If we represent the numbers by number of loops in Lissajous figures, by loops, this being the area bounded by two peaks vertically aligned either side of the x-axis, the number to be represented will be decimal values from 0 to 9. From there, we can create all numbers required to indicate the time in 24-hour format. Step 3. Numeric layout. The numeric layout is the somewhat directed by components being used on this project. This being by the resolution and physical size, display screen is organized as 4 equal sized quadrants. Top row represents hours, the bottom row represents minutes. The example shown display the time as 16:3:2. Step 4. Font panel layout. Physical layout is arranged in the following manner. Display area shows the time as Lissajous figures. Second are indicated by line that increase in length from left to right. The buttons on display PCB are programmed to functions A hours, X minutes, and B set. However, due to small size of buttons, larger easier controls were fitted. Additionally, the display is fitted behind a clear acrylic screen for protection, making the buttons inaccessible. Sounder indicates our interval controls. Step 5. Display cutout. A cutout is made for the display 55 mm multiplied by 35 mm. A top of a display cutout is located 15 mm from the top of the panel and 22.5 mm in front of the edge. Drill a series of holes with the Perimeter of the display cutout area is large enough to accommodate a small hacksaw blade. With the saw cut out the section in the display area. Level the sides of the cutout with the file. Step 6. Sounder cutout. The sounder is situated behind a circular grill. The grill a hole with a 43 mm cutout measures 85 mm down from the top of the panel and 50 mm in front of the edge. At the position with the holes are cut out a 43 mm hole. Controls cut out measures 25 mm of the bottom of the panel and mark a horizontal line at 22 mm from the edge. Along this mark with the positions and make a 8 mm hole at 50 from the edge. Along this line, mark the position and make a 9 mm hole. Countersticks the hole from the front of the panel to enable the looking nut to sit shift below the levels of the front surface. Display frame. The opening is created by drilling holes large enough to enable the saw to fit. Once most of the centers has been sawn out, the remaining material is filled away by extending lines horizontally and vertically from the inner and outer boundaries to create a square in each corner. In these corner squares, the two diagonal lines drawn from opposite corners across it to identify center of square. Display protection. The display has a protective cover in the form of 3 mm acrylic sheet. This sheet is rectangular section with dimension 70 mm. The brass frame is placed over the protective cover and the corner holes in the brass frames are used as alignment markers where 2 mm holes are drilled. Step 10. Control highlight. Control arcs backed by brass. The dimensions are 90 mm, 35 mm and rectangles has corner clip. This is achieved by mirroring both horizontally and vertically. Between 3 points a line is drawn by extending lines horizontally vertically. Apex opposite sides are close offset from each corner is created. At this crossing point 2 mm holes are drilled to fix the plate to front panel. This panel has 3 holes which align with the holes in the panel for the control. Step 11. Pico support board. A support board is placed between front panel and pico dual expander. Supporter board is attached to the front panel at the rear by 4 M2 boards. Deck 1 used to connect all the control elements. Deck 2 is used to connect to display. Due to positioning and orientation of the dual expander and the requirements to access the connections, this is at the same time mounted to the stepwise interposer boards. The interposer boards are made from strip boards in addition to SIL pins and sockets. The strip boards dimensions are 20 holes, 8 holes. One board connects to the pins on the dual expander using SIL sockets which are connected to the 2 outer 20 holes. SIL pins are inserted facing in the opposite directions to the sockets to create 2 columns of 20 pins, each with a gap between the tracks in the gap of cut isolation. Schematic. Step 4. Coding. The coding is written in MicroPython. Panel assembly. Place the brass display over the display protector and align with the corner holes. Align with the corner holes on the panel. Fit the Pico support board in the place and secure with 4 M2 boards. Plug the Pico into the dual expander in the center DIL sockets. Place the dual expander in the Pico support aligned such that the USB-C socket is pointing downwards. Fit the 2 flat clamps over the dual expanders. Insert the rotatory switch and the push button switch in the remaining holes and secure the place. Fit the brass plates over the control spindles and secure in the place with 4 M2 bolts. Step 16. Enclosure. The cavity is 134 mm and 80 mm and the full depth of the sandwich. The inner was removed by cutting into the perimeter of the dimension using a oscillating multi-tool. The oscillating plan has a distinctly deep grooved pattern, but wanting more smoothness, this requires standing in front and back enclosure such that grooved expressions were less than 1 mm for a maximum of 4 mm. Once the inner has been removed, the pieces are permanently held in places by M4 bolts. These are held by 4 insert nuts fitted at the back of the enclosure. Drill 4 5 mm holes, 17 mm in front of the edge at the back and 6 mm above the top edge of the cutout and 6 mm below the bottom edge of the cutout. The top and bottom of the enclosure is capped with the black acrylic sheet. These are both 40 mm, 65 mm, 5 mm. Step 17. Front panel fitting. Front panel fitting is to enclosure by 450 mm M4 bolts. Once a marked, use a 4 mm drill to make the holes in front of panel. Step 18. Troubleshooting. Troubleshooting may be required should it not work as expected. Check for shorts due to solder bringing between tracks and metal sheeters from the cut tracks or track not cut. Step 19. Operation. Setting the time. Step 20. Finally, another project to add selection. Hope you found it informative. Thank you so much.